Lesson: Core Principles of Cybersecurity. Cybersecurity, a critical domain in the digital age, is founded on several core principles that ensure the protection of information systems from threats and vulnerabilities. These principles are confidentiality, integrity, availability, authenticity, and non-repudiation. Understanding and applying these core principles are essential for enhancing cybersecurity measures, especially when integrating advanced technologies such as artificial intelligence. Confidentiality ensures that sensitive information is accessed only by authorized individuals. It is maintained through encryption, access control mechanisms, and stringent policies. For instance, encryption transforms readable data into an unreadable format, which can be deciphered only by those with the appropriate decryption key. This prevents unauthorized access to data during transmission or storage. According to Smith, encryption is a fundamental technique in protecting data confidentiality, especially in sectors like finance and healthcare, where sensitive information is frequently handled. Integrity involves maintaining the accuracy and consistency of data over its entire life cycle. Integrity is compromised if data is altered by unauthorized individuals or processes. Mechanisms such as checksums, hash functions, and digital signatures are employed to verify data integrity. For example, a hash function generates a unique value from data, which changes if the data is altered. This allows systems to detect unauthorized modifications. Jones and Bartlett emphasize that integrity checks are crucial for preventing data corruption and ensuring reliable information for decision-making processes. Availability ensures that information and resources are accessible to authorized users when needed. This principle is critical to maintaining the functionality of information systems, especially in critical infrastructure such as healthcare, finance, and energy. Denial of service attacks, which overwhelm systems with excessive requests, threaten availability. Implementing redundancy, load balancing, and robust incident response plans are essential strategies for maintaining availability. According to a report by the Ponemon Institute, the average cost of a data center outage due to DOS attacks is over $740,000, highlighting the economic impact of compromised availability. Authenticity verifies the identity of users and systems, ensuring that the entities involved in communication are genuine. This principle involves mechanisms such as multi-factor authentication, digital certificates, and biometric verification. For instance, MFA requires users to provide multiple forms of identification, such as a password and a fingerprint, to access a system. This reduces the risk of unauthorized access due to compromised credentials. According to a study by Google, implementing MFA can block up to 99.9% of automated cyber attacks, underscoring its effectiveness in enhancing security. Non-repudiation ensures that the origin and integrity of data are undeniable, preventing parties from denying their actions. Digital signatures and audit logs are common methods to achieve non-repudiation. Digital signatures, which use cryptographic techniques, provide proof of the origin and integrity of a message or document. Audit logs record system activities, providing a trail of evidence in the event of a security incident. According to Stallings, non-repudiation is vital for establishing accountability and trust in digital transactions, particularly in e-commerce and legal contexts. These core principles of cybersecurity are interrelated and collectively contribute to a robust security posture. For instance, ensuring confidentiality without compromising integrity or availability requires a balanced approach. Implementing AI in cybersecurity can enhance the application of these principles. AI algorithms can analyze vast amounts of data to detect anomalies, predict potential threats, and automate responses, thereby improving the efficiency and effectiveness of cybersecurity measures. For example, AI-powered intrusion detection systems can monitor network traffic in real time, identifying suspicious patterns that may indicate a cyber attack. According to a study by Kumar and Garg, AI-based IDS can achieve a detection accuracy of over 90%, significantly reducing the time to identify and mitigate threats. Additionally, AI can enhance authentication mechanisms by analyzing behavioral patterns, such as typing speed and mouse movements, to detect and prevent unauthorized access. However, the implementation of AI in cybersecurity also introduces new challenges. AI systems themselves can be targeted by adversarial attacks, where attackers manipulate inputs to deceive the AI. Ensuring the security and reliability of AI models is critical to maintaining the core principles of cybersecurity. Research by Goodfellow, Bengio, and Corville suggests that developing robust AI models resistant to adversarial attacks is an ongoing challenge that requires continuous innovation and adaptation. Moreover, the integration of AI in cybersecurity raises ethical and privacy concerns. AI systems often require access to large data sets, which may contain sensitive information. Ensuring the confidentiality and integrity of this data is paramount. Ethical considerations, such as bias in AI algorithms and the potential for misuse, must also be addressed. According to Binns, developing transparent and accountable AI systems is essential for maintaining public trust and ensuring ethical use of technology. In conclusion, the core principles of cybersecurity: confidentiality, integrity, availability, authenticity, and non-repudiation form the foundation for protecting information systems from threats and vulnerabilities. Implementing these principles requires a comprehensive approach, leveraging advanced technologies such as AI to enhance security measures. However, the integration of AI also presents new challenges that must be addressed to ensure the effectiveness and reliability of cybersecurity solutions. By understanding and applying these core principles, organizations can create a resilient security posture that safeguards their information assets in an increasingly digital world.